Okay, we're going to look at section 5.1 for this. This is systems of equations. So this should be a familiar topic from Algebra 2, okay, when we talk about systems and things like that. And we are going to discuss things that happen. So when we have linear equations, okay, we are basically talking let's get that straightened up a little. Okay, now this may be something like 3x plus 8x minus 5x or something like that. The idea is we will be able to condense this down to like a 6ax equals b. Okay, that's the thought process that's going to happen here. We may even have like ax plus a number. Okay, so ax plus c equals b. Okay, something like that. As this is processing through. Okay. Now then, this is called a linear equation. Okay, it is a first degree. We've talked about degree before, because of the fact that it is just a single powered x. We don't have like x squared or anything like that. Okay, so now when we talk about a system of equations, okay, a system of equations is two or more equations, okay, and a solution must satisfy, so this must satisfy all equations, okay, which means it has to work in order to be a solution, okay? Now then, if all of the equations in the system are linear, then it's a linear system of equations, okay? So now a couple things that we're gonna talk about here, okay, is when we're looking at kind of solution things here, okay, if here's a line and there's a line, okay, and so if they intersect at one point, okay, then the system is called consistent. Okay, consistent just means that it has an answer. Okay, the equations, so it's a consistent system, the equations are independent. Okay, and I view that kind of as I can see each line on its own. Okay, so now if we talk about a system where stuff is going to run parallel, we know that these are never going to cross each other, so that's, we're not going to have an answer for this. This would be a no solution, okay? So the system is inconsistent. Again, consistent or inconsistent means that I'm getting an answer, I'm not getting an answer. And then the equations are still independent, because we can still see both equations on their own. Okay, now there is a third method, or a third option, excuse me, a third option that we have. And that is that the two equations are the same line, okay? Now, first off, this has infinitely many solutions, because any point that I pick on one is automatically on the other, and I can sit here and keep doing this forever. Okay, do not confuse this with all reals. If you say all reals, that means that dot works. That dot is not a solution on that one, okay? So it's infinitely many. The system is consistent, because I do get an answer. I get lots of answers. The equations are dependent. And that is because when I get one equation, I'll automatically get the other equation, okay? So the first method, okay, that we are going to look at for solving, okay, is the substitution method. Okay, now remember that with substitution, you are solving one of your equations for one of your variables, and you're going to replace that up into the other one. So the system that we're going to look at, okay, is this one. Now, the easiest letter here to solve for is going to be this y in this equation, okay? So we're going to solve for that y in that equation because it's already positive, and I'm not going to have to do any division. Now, I'm going to intentionally write this in a separate color, okay? So we've got that y now equals 3 plus x. And then what we're going to do is in the other equation, I'm going to replace the y with what we say y equals, okay? So now I've got 3x plus 6 plus 2x equals 11. We're going to get 5x plus 6 equals 11. 5x equals 5. X equals 1. Once you know what x is, you need to go back and plug that back in to figure out what y is. You can go here, here, or you can go here. I like to use this one because I've already got the other letter by itself. So then y is going to be 3 plus 1. So y is going to be 4. Now, they may ask for it in the separate stuff. If not, write it in an ordered pair format, but do make sure that you are doing x, then y. Okay? X, then y. So, now then, substitution can sometimes get a little bit messy if you have coefficients in front of all your variables, okay? Because you might wind up with fractions and you're having to deal with those. So, the other method, now, you also have the option to graph these, but unless you know you're always going to have a graphing calculator at your disposal, you may or may not always be able to use graphing, okay? And if you're going to hand graph, you got to make sure that you can actually, they're pretty graphs, okay? Meaning their y-intercept is nice. The rise run works really well. That slope run works really well. Also, that if they do intersect, they intersect at a pretty point, okay? Because if they're in between values, that can become difficult, okay? Now, with our elimination, okay, we want same amount, opposite signs on one of our variables, okay? So I want a 3x and a minus 3x. Negative 9y, positive 9y. And then we're going to add those two things together, okay? Now, in order to make this happen, you can multiply one line or both lines by any value that you want. They don't have to be the same value. You do just have to make sure that you multiply the entire line by something, okay? So, let's take a look at one of these. Okay, so with these, usually I start thinking about going up through their multiples. Where do we match it? So 3 and 2 are going to match at 6. 4 and 3 are going to match at 12. So we're going to make our x's match. So we're going to do this one by 2 to get it up to 6. We're going to get this one up to 3. Now, we do need one of these to be negative because they're both positive currently. Okay, so I'm just going to stick the negative on the bottom one. So on the top line, that's going to give us 6x minus 8y equals 2. Negative 6x minus 9y equals negative 36. And then we're going to add. The x's are going to cancel. So we've got negative 8 plus negative 9 is going to be negative 17y equals 2 plus negative 36 is negative 34. Divide by negative 17, and we get that y is 2. We're now going to plug that back in up here. I'm going to choose this second equation, okay? So I've got 2x plus 3 times 2 equals 12. Subtract the 6, divide by 2. Okay, now do be careful if you're going to write this in ordered pair that you actually do x, then y. Okay, don't do it in the order that you found them. Make sure you're still writing it in x, y ordered pair setup. Okay, so take a look at another one. Okay, so 3 and 6 will match at 6. 2 and 4 will match at 4. So I'm going to make the y's match up this time. So this one's already a 4. So I'm just going to have to multiply the upper line to get it up to a 4. I also have that these are already in opposite signs. I have a negative and positive, so I don't have to worry about getting a sign switch like we did in the last one. So multiplying the top line, I've got 6x minus 4y equals 8. Negative 6x plus 4y equals 7. Now, x's cross off, but wait a second. We were trying to make the y's cross off, but they do as well. That means I have nothing on this side, and I have 15 on that side. Now, guys, if this happens, that all of the letters cancel out, you have to decide if this statement is true or false. If this statement is false, like it is in this case, then you have no solution, okay? And that means that these original two lines, okay, or these original two equations, if they were graphed, would be parallel, okay? So this, if you get that all of the variables go away and all you have left is numbers and it is false, then that means no solution. Now, do not let that be confused with getting something like x equals 0 or y equals 0. X equals 0 or y equals 0 just means that that is the value of that variable, okay? I see a lot of students that try and they have a little bit of an issue when that comes up, that you get 0 as an answer, okay? Okay, so for this one, we've got 8 and 4 will match at 8. 2 and 1 will match at 2, so I'm going to make this one line up this time. So again, I'm going to make the y's line up down here. So top line, I didn't change anything. Multiplying on that second line, I got negative x plus 2y and then 4. So we're going to add. So we've got these go away. The y's go away, so I have nothing on this side, and I get 0 on that side. So 0 does equal 0, so this is a true statement, okay? Which means this is infinitely many. Okay, so that is infinitely many. Now then, the concern with these, okay, is going to be, okay, so we have that it's infinitely many, that means these two are the same lines. Sometimes, and I'm going to show you this notation, I don't have a way to know or be able to say, because the stuff, if I pick an x, then that's going to dictate what the y is. So sometimes what you will see them do here, okay, is if I take this second equation and I solved it for y, I would have 4x plus 2. Okay, so sometimes what you'll see them write is x, comma, 4x plus 2. Okay, meaning you pick me an x, so if I pick like 1, then when I plug in 1 over here, it has to be the number 6. Okay, and that would be 1, 6 would be an ordered pair that works up here. Okay, if I pick something like negative 2, that would be negative 6. Okay, so I'd have negative 2, negative 6 would be plugged in, and that would be my ordered pair up there. Now, sometimes they may have y, and then they've solved one of these equations for x, so that it's x equals, and they'll put that in the x spot. So just be mindful of the fact, okay, that this is sometimes how that you will see them write these infinitely many solution things, okay? So now we're going to get into kind of our word problems type of stuff for this, so that we can see some of these working. Now, we should be able to, you don't have to use x and y for your variables. You can use whatever variables you want to, and certainly if things make sense to use one thing or the other, then use them. but you don't have, you're not restricted to it's got to be X's and Y's, okay? So we've got salaries in the same position can vary depending upon location. In 2010, the average salaries for the position of accountant 1 in San Diego, California, and Salt Lake City, Utah, was $45,091.55. Okay, so $45,091. This is the average salaries of those two. Okay. However, the salary in San Diego, okay, so the San Diego salary exceeded the Salt Lake City one by 5231. Okay. Let's get one back here. Okay, so this was the average. Okay, and this exceeded. So I'm going to use D for San Diego and C for Salt Lake City for this. So to find average, you add and divide by 2. And then I've got that San Diego exceeded, so that means it is higher. Okay, so for this top equation, just to clean this up, I'm going to multiply by 2 and get that 2 kicked over to the other side. Now, this is set up really nicely for substitution because, guys, I've already got D equals this. So I'm going to replace this. So I have C plus 5231 plus C equals so I subtracted, and then I'm going to divide by 2. So Salt Lake City is 42,476. So then if I do D is 42,476 plus that 5231, we get that that is 47,707. Okay. So San Diego's, Salt Lake City's. Okay. Now, is that the only way to do the problem? No. I just picked that based on the fact that I had this nice, pretty already solved for a letter equation right here. Okay. And so that's just the way that I opted to do that. Okay. Now, I could have also taken this and plugged it in up here. Okay. It would have been some of the same solving stuff. Again, there's kind of more than one way to do this. Now, the other thing that we've got to look at is 3 variable systems. Okay. Now, with 3 variable systems, okay, what we're looking at is you need 3 equations with 3 variables. So normally you see this done with X, Y, and Z. Okay. Those are the traditional letters that we see done. Now, if you're trying to visually understand what's going on here, okay, when we do 3D, this is flat surfaces, okay? So one of the equations might represent a wall in your house, okay? Now, another system might represent a wall that intersects that. Now, when those two come together, you have that entire scene from ceiling to floor, okay? So you've got kind of this is coming in here, and you've got this is coming off this way, okay? So you've got this is one surface, this is one wall, this is another wall, and so right now where these two, and this would kind of extend that way, and that would extend that way, okay, if they extend it on forever, okay? So right now we've got everything on here. Now, when you tack in the floor is another surface, the solution is that spot right there in the corner, okay? Now, we also have some of these things can intersect in a couple of different ways. PowerPoint over so that you can see these a little bit better. Okay. I'll let my stuff catch up to me. Okay. So this one is we've got kind of, they almost do like a starburst type idea, okay? And guys, this would be an infinitely many, because we've got that entire line that all three of them are coming together in, and that would be, we also have infinitely many that occurs if all three of them are the exact same plane, okay? So if they all three represent like the same wall in your house, then you have this. This would almost be kind of like a fun house mirror setup where you've got lots of mirrors coming in all at the same area, okay? Now, for no solutions, okay, there's a couple of ways that we can have no solution show up. One is they can be stacked like the floors of a building, okay? So first floor, second floor, third floor, they're never going to intersect, okay? You could also have two of them running like floors of a building, and the third one is slicing down through both of them, okay? And so you can have that third one is slicing down through the middle for that, okay? Now, another option for no solution is going to be if they do kind of like a tent shape, okay? Where you can get any two of them to come together, again, kind of forming a seam, but you don't ever get all three of them. Or you can have this one, this is kind of a version of the stacking one. Two of them are the same, but one of them is different, but they're still stacked in parallel. And all four of those last ones that I showed you are all no solution setups, because you can never get all three of them to come together and hit in one spot, okay? So usually with this, and we're going to see some other methods, but for right now, we're going to work with the elimination method of the solving method. We are going to look at another solving method here in another section, but for right now, we're going to work with the elimination. Now, what's going to happen here is we're going to get what's called an ordered triple, okay? And an ordered triple is going to look like X, Y, Z, okay? So we're still keeping them in order. So we've got X, Y, Z in order. That's going to happen here. Now, when we do elimination, what's going to happen? I'm going to kind of process this example, explaining it as we go along. Okay, now what's going to happen is we have got to partner pair two of these equations together and get rid of a letter. Then we've got to partner pair two other ones together and get rid of the same letter, okay? Now, looking at the coefficients on our x's, 3 and 2 and 1 will all match up at 6, so I probably have to match them out at 6. 9 and 1 and 1 is all going to go at 9, and 6 and 1 and 1 will all match at 6. I do like the fact that right here I've already got a minus z plus z. So what I'm going to do first is I'm going to take this one and this one, and I'm going to partner pair them together. I don't have to change anything with them, okay? So I'm going to do this in this kind of red color. Hopefully it comes across as red. And we're going to add these up. Okay. Now, I'm going to partner pair two others of these, and I've got to get rid of the z's. Now, I'm going to use this one because I've already got that negative z in there, and I'm going to partner pair it with this, okay? Now, the other thing, though, that I'm going to do is I'm going to multiply this whole line by 6 when I come down. So my top line is 3x plus 9y plus 6z equals 3, and then multiplying by 6, that's going to give me 12x plus 6y minus 6z equals 12. And we're going to add these up. So I've got 15x, 15y, those are going to go away, equals 15. Okay, so now what we're going to do is we're going to partner pair these two together and get rid of a letter. So 3 and 15 will match at 15. 2 and 15 match at 30. So I'm going to make the upper one match. So I'm going to multiply this by -5. Okay. So I'm going to have negative 15x minus 10y equals negative 20. 15x plus 15y equals 15. And we're going to add. Put this in this color. That's going to give me 5y equals negative 5. So y is negative 1. Now, from here, okay, I've got to go back to one of these two equations where I had just x's and y's and plug it back in. Now I'm going to go back into this smaller one. So I've got 3x plus 2 times negative 1 equals 4. It's got 3x minus 2 equals 4. Sorry, I'm going to try to keep this all together. 3x equals 6, so x equals 2. Okay, so I've got x, y. Now, I'm going to go back to any one of those original 3, and I'm going to plug it in. So I'm going to go into this bottom one, the x plus y plus z equals 2. I'm going to come back down here. Oops, sorry. Getting a little unstable here. So I'm going back to that x plus y plus z equals 2 equation. X is 2, y is negative 1 plus z equals 2. So I've got 1 plus z equals 2. So z equals 1. So to write my system answer, my ordered triple, it's x, y, z. So there's my solution to that one. Okay. Now then, you can still get infinitely many and no solution, okay? With these equations, they can still happen, okay? Now, the traditional rule is the number of variables that you have is the number of equations that you are going to need. So if I were to see this, okay, the concern that I have is that I'm only given 2 equations. That means that this is going to be an infinitely many because I don't have enough. They've only given me 2 of the 3, okay? So what's going to happen here is they will probably have you solve for x and then replace that in so that you get y and z, but that you can rewrite those in other termings for other letters, okay? So again, kind of the way that this works here is solving through, and then again, once you pick one of your variables, you've got to pick another. Now, one of the applications that we see used here is if we're going to work with this equation, okay, if they wanted to find us one and they gave us ordered pairs, okay, the way that this is set up, okay, is we know that this is the answer when we plug in 2. So if I create this, I'm going to have 2 squared is 4. So I have 4a plus 2b plus c equals 4. Okay, so I plugged in 2 for x. So I did 2 squared is 4, 2, and then I didn't have anything in my answer is 4. So now plugging in negative 1. Negative 1 squared is 1, so it's going to be a. Negative 1 times b is going to be negative b. C is the same, and that's supposed to equal 1. And then plugging in negative 2 squared is going to be 4, so I've got 4a. Negative 2 times b is going to be negative 2b, and then c doesn't change, and that's supposed to equal 5. Okay. Now, and now we're back kind of in the same boat. So, first off, okay, it would make sense to get rid of the c's, okay, because they have, they're all singletons. But I also notice here that it would be really simple to put this one and this one together and then partner pair these 2. So I'm actually going to make my b's go away. I'm going to match up this one and this one. Okay, so I'm going to have because I don't have to do any changes to them. If I was going to do the C's, I would have to make a sign change happen. So we're going to add. It's going to give me 8A plus 2C equals 9. And then I'm going to partner pair this one and this one. And I am going to multiply the second line by 2 so that I get the 2B and the minus 2B. So 4A, 2B plus C equals 4. And then 2A minus 2B plus 2C equals 2. Give me 6A, those go away, plus 3C equals 6. Okay, so I'm just going to kind of write this one up under here, and then I'm going to figure out what I need to do to make a match. Okay, so for this one to get a match up, these are going to match at 24. These are going to match at 6, so I'm going to multiply this one by 3, this one by a -2, okay, to make that happen. So I'm at 3 times 8 is 24 plus 6, or sorry, 24A plus 6C equals 27. -12A minus 6C equals -12. Add. It's going to give me 12. Those go away. And that is going to be 15. Okay. Dividing through, I get A is going to be 1.25. I'm going to bring that back into one of these equations. So I'm going to bring it back into my green one right here. So I have 6 times 1.25 plus 3C equals 6. So I get 7.5 plus 3C equals 6. 3C equals -1.5. C equals -0.5. Okay. And then I'm going to go back into this A negative B C one. So I have 1.25 minus B plus -0.5 equals 1. So I've got negative B plus 0.75 equals 1. All right, move down so you can see. Negative B equals 0.25. So B is going to be -0.25. Okay. So now, using those pieces of information, we're going to go back into my equation. This is 1.25x squared minus 0.25x minus 0.5. And there is my equation for that. Okay, so that's where they use a quadratic to make that happen. Okay. So, we've got one more, okay, that we're going to look at. Okay. So, and this one is, they're talking about an animal feed. Okay. And so they give us a table, and I'm going to kind of abbreviate the table. We've got protein, fat, and fiber. Okay. And then corn, soybeans, cottonseed, and then there is a total amount that they need to get of each of these items, okay? So I'm just going to kind of fill these in. Okay, so the concept here is that how many units, because they want to get 22 units of protein, they get 0.25 of a unit from corn, 0.4 of a unit from soybeans, and 0.2 from cottonseed, and so on. So the idea here is this becomes your X, Y, Z, because I'm trying to figure out how many units of corn, soybean, and cottonseed should I be using. So I'm going to have the equation 0.25x plus 0.4y plus 0.2z equals 22. 0.4x plus 0.2y plus 0.3z equals 28. And 0.3x plus 0.2y plus 0.1z equals 18. Okay, so this now becomes our system of equations that we're now using. Okay, okay, so let's play games here. I like the y's, okay, right here. So I'm going to take this one and this one, but I'm going to have to multiply by a -2. Okay, for this one, so I've got 0.25x plus 0.4y plus 0.2z equals 22. -0.8x minus 0.4y minus 0.6z equals -56. Okay. So that's -0.55x, those go away, minus 0.4z equals -34. Okay, bring this down. Okay, then I'm going to partner pair. I'm actually going to partner pair this one and just multiply with a -1. Okay, so I've got 0.4x plus 0.2y plus 0.3z equals, 28. We've got -0.3x minus 0.2y minus 0.1z equals -18. So it's going to be 0.1x, 0.2z, so it's going to be plus, equals 10. Okay, so now I'm going to have to put these two together. And what I'm going to do with that one, pull another color here. Hopefully I'll be able to see this, okay? When I bring these two together, I'm going to multiply this one by 2, okay? Because I've already got 0.2z, and I've got a -0.4 here, okay? So writing up what I'm fixing to have, I don't know if the green will stay with me, but okay. 0.55x minus 0.4z equals -34. That's going to be 0.2x plus 0.4z equals 20. We're going to add. So I'm at -0.35. These go away. Equals -14. Divide. And we get x is 40. Okay. Now, I'm going to go back into, hopefully this will all stay steady for me. Okay. I'm going to go back into this dark green equation that I have right here. Okay. So I've got 0.1 times 40 plus 0.2z equals 10. So that's going to be 4 plus 0.2z equals 10. 0.2z equals 6. Z is 30. And then going back to one of these upper equations, I'm going to go to this bottom one. I've got 0.3 times 40 plus 0.2y plus 0.1 times 30 is 18. This is going to be 12 plus 0.2y plus 3 equals 18. That's going to give me 15. Subtract it over. 0.2y equals 3. That's going to be y is 15. So now bringing this all back together, okay, that means I need to have 40 units of corn, 15 units of soybeans, okay, and 30 units of cottonseed, okay? So this is one where you're going to have to bring back the variables and what those variables represented back from the top end, okay? So now we are going to see in the next couple of sections other ways to solve, especially when we get up into these 3 variable systems, other options for how to solve these.